Welcome back to our semi-final or week module number 6. So our topic, continuation from our module 5. So our topic will be unbalanced delta connected loads. So the solution of the unbalanced delta connected load consists in computing the phase currents and then applying KCL to obtain the line currents. The currents will be unequal and will not have the symmetry of the balance case since unbalanced, so therefore ang atuang currents will be unequal. So dili siya same sa atuang balance case from module 5. So we have here our figure. So if we have delta, so when we say delta, we have our figure just like a triangle. And then from our A, so we have B and C. So kana na ay naga-travel ana na current which is IA, IB and IC. And sa ato ang delta, so naatay loads which is ZAB, ZBC and ZCA. So sa kana na loads, naa na siya current which is current from A to B and current B to C and C to A. So take note that ZAB is not equal CBC and CCA since load is unbalanced. So solving for our current along A to B, so we have our formula. So since current is equal to voltage over the impedance. So current of AB is equal to the voltage of AB divide the impedance of A to B. So same sa IBC and ICA. So dapat same ang ilahang variable when you solve for the current. So after, apply KCL on the three junctions. So unsa maning KCL? So mao ni siya sa inyuhang circuit 1. Mao ni siya ang Kirchhoff's current law. So kaning KCL is current enter is equal to current leaving. So we have our IA, so we have IAB. So solving for IA, we have IAB minus ICA. And same for solving for the current B, we have IBC minus IAB. And solving for our current C, we have ICA minus IBC. So let's try to solve. So from our example, so a three-phase 120 volt supply has a phase sequence of ABC and delivers power to a group of delta connected impedance whose values are CAB 10 plus J0, CBC is 5 plus J 8.66 and ZCA is equal to 8.66 plus J5. So solve the total active power drawn. So giingon sa atong problem nga delta connected impedance. So we know that if delta, we have our figure like a triangle and naay naghatag siya og 3 impedance which is CAB, CBC and CCA. So giingon pod nga we have also an ABC phase sequence. So sequence na to, we have AB, angle of 0, and ECA and EBC. So kani naa na siya sa tuang last topic. So formula to solve for the current A to B since naa na siya ang formula base. So giingon nga naatay given nga voltage which is 120 volts. And naatay ZAB which is 10 plus J0 and CBC 5 plus J 8.66 and ZCA 8.66 plus J5. To solve for current, so we have IAB 120 divided by 10 plus J0. So in our calcu, we need to convert in complex. Since naka-complex ang ato ang impedance. So we have 120 with an angle of 0 degrees and our impedance, which is 10 plus 0 shift and I sa atong calcu. So our answer will be 12 amperes for IAB. And for IBC, so 120. So same ra, 120 ang ato ang voltage with an angle. So makita na to sa atong phase sequence. Ang angle BC is here we have our, so ang angle is negative 120. So therefore, ang ato ang angle sa atong voltage is negative 120 degrees. Divided by sa atong impedance sa BC, we have 5 plus 8.66 I. So our answer will be, so we need to convert in polar form. So complex, number 3. So our answer will be 12 with an angle of negative 180 degrees ampere. So we have our IBC. So solving for ICA. So sa atong ICA, makita nato ang ato ang phase sequence. So ang angle sa atong ICA is positive 120 degrees. So solving for ICA, we have 120 voltage with an angle of positive 120. And our impedance for CA, which is 8.66 plus 5 I or J5. So our answer will be, convert in polar form, 12 with an angle of 90 degrees ampere. So since nakuha na to ang tanang current, so pwede na nato ma-solve ang atuang unknown, which is the total active power drawn. So our power total will be power along AB plus power along BC and plus power along CA. So for our formula sa tong power, so we have, if natay current, I squared multiply sa tuang R. So solving for our total power, since nakuha na nato atong current in every impedance, so we have IAB, which is 12 squared multiply sa atuang resistance, which is 10, plus sa itong IBC, same, we have also 12 squared with an multiply sa itong resistance, which is 5, plus sa itong CA, we have our current na same gyapon, which is 12, and multiply sa itong resistance, which is 8.66. So our total power drawn will be 3,407.04 watts. So we have here our final answer. So let's proceed to our another topic. So we have also unbalanced Y-connected loads without a neutral connection to the source. So the unbalanced Y is converted to its delta equivalence and analyzed as unbalanced delta loads. So makita na to nga naatay given nga unbalanced Y. So we know that the figure for Y connection is just like an inverted Y. And for our delta, So, nakabalo na mo ani sa inyohang circuit 1. So, you like a triangle. So, sa Y, naapod siya given nga impedance which is CA, ZB, and ZC. While sa delta, ZAB, CBC, and ZCA. So, giingon diri nga Y is converted to delta equivalent. So, our formula for Y i-convert sa atoang delta, we have ZAB is equal ZA, ZB plus ZB multiply to ZC plus ZZ multiply to ZA over ZC, or our total impedance equivalent. And for our ZBC, same, Z equal equivalent over ZA, and for our ZZA is equal to Z equivalent, impedance equivalent over ZB. So let's apply in our example for unbalanced Y. So we have a 440 volts balanced 3-phase supply feeds a star-connected load consisting of 3 resistances of 10 ohms, 5 ohms, and 12 ohms respectively, connected to lines A, B, and C. Calculate the voltage drop in the 10 ohms resistance. Assume an ABC phase sequence. So we already know the figure. So we have here our Y connection. So i-convert to delta connection. So solving for ZAB, since kabalo na to sa tong formula from the above, so giingon nga naatay given nga CA which is 10 ohms. Our CB is 5 ohms, and we have our CZ is 12 ohms. And napoy given nga current which is 440 volts. So solving for ZAB, since given tanan ang atong impedance from A to C, so we have for our ZAB, so we have all CA, so we have 10 multiply to 5 plus ZB multiply to ZC which is 12 plus ZZ multiply to ZA. So 12 times 10 over the ZZ which is 12 ohms. So our ZAB will be 19.166 ohms. And also, we need to solve for our ZZA. So since same rang ilang equivalent, so we have our 230 over 5, which is the ZB, 5 ohms. So our ZCA is 46 ohms. Since ang giingon si problem, ang voltage drop along 10 ohms, so we need to solve for the current IA, current along A. So kabalota for our formula for current along A, apply KCL. So we have IA is equal to IAB minus ICA. So kaning IAB, so I is equal to E over Z. Since natay given na current and our impedance. So take note, gaingon sa problem nga ABC phase sequence. So our angle will be EC, our ECA, and EBC. So solving for our current along A, so we have 440. We need to convert first in complex. So 440 with an angle of 0 ang atong ECA divided by sa atoang ZAB na answer na to ganina na solve, which is 19.166 minus, so sa atong ECA, which is 440 with an angle, so based sa ato ang phase sequence, so we have 120 degrees divided by sa ZCA nga solve nato ganina, which is 46 ohms. So our IA, just convert in polar form, so our IA will be 28.95 with an angle of negative 16.626 degrees. Since ang gipangayo sa problem is the voltage across a 10 ohms resistance. Since na-solve na nato ang atuang current along A, so pwede na nato ma-solve ang voltage drop for ZA. So EA is equal to IA multiply to ZA. So ang atong IA is 28.95 from our na-solve na to, and our ZA from our problem is 10 ohm. So our final answer will be 289.5 volts. So it's very easy, no, since it is a formula base. So next for our topic for our semifinal, so unbalanced Y-connected loads with a neutral connection to the source. Since a neutral point of the load or a balanced Y is connected to the neutral point of the source, the phase voltage of the load is equal to EL divided by our E3. So since ang giingon katong ganina wala toy connection or neutral point, so here in our topic we have our N, which is the neutral point. So we have our IN in a Y connected loads. So for our formula for unbalanced Y connected load, if natay neutral point, so we have here IA is equal to EAN over ZA, and our solving for IB, EBN over ZB, and for our IC is ECN divided by ZC. So solving for IN, or the current flowing in the neutral conductor, so we need lang to add all the current nga na-solve. So let's apply in an example. So for our last example, we have an unbalanced 4-wire star connected load is fed from a 3-phase balanced supply of 440 volts. The load connected in lines ABC respectively are ZA is 10 plus J 0 ohms, ZB is 5 plus J 10 ohms, and ZZ is 15 minus J 5 ohms. Solve the current in the neutral wire. Assume a phase sequence of A, B, C. So natay given nga CA, which is 10 plus J 0 ohm. Our ZB is 5 plus J 10 ohms, and ZZ is 15 minus J 5 ohms, and our voltage is 440 volts. So we know, sa giingon dito sa taas, ang unbalance na to is we need to divide EL divided by square root of 3. Since phase voltage, so we need to convert. Since ang gihatag sa 2A is 440 which is line voltage. So EL divided by square root of 3, we have 254 volts in our EP. Since natay neutral point sa ato ang Y-connected loads, so we have here in our figure, we have nagflow nga current within the neutral point. And our ABC phase sequence, so kabalo na tana. So nganong na negative 120, since na siya sa ubos, since pa counterclockwise ang atuang travel, so we have positive 120. So solving for our neutral point, so we need lang to add all the current from our impedance loads. Since naa na tay neutral nila nga voltage, so we need to use for our calculator. So convert in complex. So EAN, which is 254 with an angle of 0 sa tong phase sequence, divided by our ZA nga given 10 plus 0I, then plus sa EBN sa neutral 254 with an angle of, so sa tong phase sequence we have negative 120, divide ZB from our given, which is 5 plus 10I, plus in our ECN, so we have 254 with an angle sa atong phase sequence, which is positive 120, divided by sa atong ZZ, which is 15 minus 5I. So solving for our neutral point in our current, so our answer will be, convert to polar form, is 15.195 with an angle of 127.72 degrees ampere. So our total, so our final answer for the current flowing in our neutral point is 15.2 amperes. So I hope na ay nasabtan for our module number 6, and you need to study for your exam, upcoming exam. And if you have any question, you can comment in our Google Classroom para matabangan ni ma'am. So that's all for our topic for our semi-final. So good luck and thank you.